All right, welcome everyone to App Deployment PaaS Battle. My name's Matt Davies. With me is Rob Moore. We'll be your hosts for this afternoon. Today you've got several options for trolling us. You can troll us in person from the front. We also have a hashtag. Encourage you to use that. But we're going to be looking through a few different PaaS options today. I guess as principal consultants at Redify, we spend a lot of time looking at all sorts of different options for deploying things. We get some experience across just about every type of PaaS deployment option that there is. And so we've seen a lot of really cool stuff in the last few years. We've seen a lot of really painful things as well. And we've channeled all that pain for you today so that you don't have to go through
more
that yourself.
Specifically in the last 3 days, in the last 3 weeks. But
yeah. So welcome and looking forward to going through some of this stuff with you today.
So what we're going to talk about is, we're going to start just briefly on the what and why of PaaS. It's probably pretty basic stuff for most people. Then we're going to talk about the comparison methodology that we're using to actually compare the different PaaS services that we're looking at. We're going to introduce an API example that we've created just for the purposes of this talk. And then we're going to go through 4 different services and we'll introduce them in a bit. And then just wrap it up for you.
Cool, very good. So as Rob said, I'm sure most of you know what PaaS is. If we just take our standard under-the-desk bare metal server that's running all our critical systems, it looks something like this on the left. You kind of have to deal with everything yourself, from storage, networking, and so on. If we look at virtual machines or infrastructure as a service, some of those concerns get taken away from us and dealt with automatically by whoever's providing the virtual machines. If we look then at platform as a service, typically we're only actually dealing with the deployment of the application itself along with any data that's associated with it. And then lastly, if we look at software as a service, that's purely outsourced to whatever vendor is providing the software as a service to us. So we don't have to worry about support or anything like that.
Of course, this is just completely wrong, because this isn't actually really what PaaS is. Because I mean, it's an okay model, but it's just not nuanced enough. And in reality, we think that this is actually what PaaS is. It's a continuum. It's a continuum where on one end, you've got pure IaaS, if you want to call it that, where you have a lot of control and a lot of flexibility. And on the other end, you've got pure PaaS, or whatever you want to call it, where you have a lot of simplicity, you've got much more reduced maintenance, but you also have a lot less access to or even knowledge of the hardware that you're running on. So if we kind of paint this continuum with a few examples, hopefully that will illustrate why this continuum is so important. So obviously you've got Amazon EC2 and Azure virtual machines. They're your typical kind of I guess pets, if you want to call them that, and then you can layer on top of that things to make them into cattle. So you've got things like VM scale sets or AWS auto scaling that allow you to just define how to spin up a VM and just say, I want 20 of them, now I want 10, now I want 15.
So make things a bit easier, but we're still dealing with the raw infrastructure itself.
Yeah, so you've got a lot of flexibility, a lot of control about what's going on there. And then you start to get more into that PaaS spectrum. And I think, in a rough sense, there's been about 3 different evolutions of PaaS. The early one is Azure Cloud Services and AWS Elastic Beanstalk. Now, these are really, in reality, a very thin wrapper over the underlying virtual machine hardware. Normally, they just add the ability to deploy an application and they add some load balancing on top. And there might be a few other little features like health monitoring and stuff like that.
But you can still RDP into the machines themselves usually and get to the guts of it if you really want to.
Absolutely, yeah. Now, the second version of PaaS is actually only really exists in Azure. It's Azure App Service, which is something that's existed for the last 5 years. You kind of know that you've got virtual machines underneath. You can even see the machine names, but you don't have access to them. They're patched for you automatically. And you just give Azure your application, and it takes care of putting it on all the machines, load balancing it, and adding on a whole bunch of extra stuff on top of it. And we'll dive a little bit more in later in the talk. The other interesting thing that's starting to emerge is kind of 2 other, I guess, types of PaaS. The first one is PaaS services where you kind of need to know about the hardware underneath because you need to provision out the hardware, or at least describe the hardware using, scale sets and auto scaling type building blocks, I guess. But on top of that, you then layer in a platform that you then interact with day to day. So your day-to-day sort of deployments, you don't need to know about the hardware underneath, but to set it up initially, you do. And that's things like Azure Service Fabric and all the container services that deploy like Kubernetes and Swarm and that sort of thing. And there was a really good talk yesterday by Michelle Bustamante about them, if you want to go and look back at the videos to get more of a feel of those. And then the other one is obviously all of the serverless technologies that are all the rage at the moment. And these ones, you don't know anything about the hardware that you're running underneath, and that's obviously why they call it serverless. Now we're going to, as I said, talk about 4 of these services. So the ones we're going to run through today is Elastic Beanstalk, Service Fabric, App Service, and Container Instances. So we've basically chosen one of each of those 4 kind of categories, if you call it that, of PaaS services. Now the elephant in the room is serverless, right? So I've been talking to a number of people about this talk that we're doing, and one of the things that came back a few times was, well, we don't need to worry about PaaS anymore because we can just put things on serverless and it's a magic bullet. Now, I guess the first thing really with that is, okay, when they say serverless, what they're really talking about is functions as a service, so like lambdas and functions and stuff like that. It's an awesome architecture, and you can do some really cool things, as evidenced by all the really great talks that are in this conference about that stuff. But that architecture, it's not a silver bullet. It's not appropriate for all scenarios. There's a bunch of scenarios where you just wouldn't use that architecture for. So in reality, the more important thing is, how do you decide what PaaS service you should use in any given circumstance? And that's really the point of our talk.
Cool. So a lot of the PaaS things that we described there were more your compute PaaS, and obviously just examples. There's a whole lot of other stuff out there. We wouldn't be able to fit it all on a slide. But specifically talking about like why PaaS, I guess there's all these benefits that emerged on top of just your raw infrastructure as a service. People wanted services that offered them a lot more scalability out of the box, not having to manage specifically how many VMs there were, but just like sliding a slider or setting some auto scale settings up, making things a bit easier. It offers a lot more benefits in terms of security. We no longer need to worry as much about patching our virtual machines. We get firewalls out of the box that cover a whole lot of stuff, DDoS protection, etc.
You've also got all of the amazing security experts in the vendor company that are going to be far more, I suppose, skilled at making things secure than the people in your own company. So
well, they've often got a lot more money to do it, I guess, than
a lot more
people does. Yeah. So security aspect is a pretty awesome benefit. It'll often take care of backups for you, depending on specifically which PaaS service you're looking at. Most of the time, things are Jira replicated out to different environments. You don't have to deal with all that synchronization yourself, which is usually a pretty hard problem as a developer. So kind of nice that it solves that for you.
It's a particularly useful thing for all of this is sort of the more data services side of PaaS, like databases and that kind of thing.
In terms of velocity, what we often say to people is that a really core benefit is the fact that you get all these developer services out of the box, so things like your SQL databases and storage and so on, but also more complicated scenarios like machine learning, where it would take you a pretty long time to build that stuff yourself, but instead you kind of just get to use it out of the box to speed up your development. It provides a lot in terms of simplicity, but as we were sort of saying before, also then takes away some control from you, depending on exactly what it is you're trying to do, and provides a whole lot of fault tolerance type functionality. So by making you think about how you're building your applications, because they're going into a cloud environment and you'll only get certain SLAs if you do things in certain ways, but also by taking care of auto-scaling, taking care of automatic failover when hardware dies, that type of thing, which just like massive benefits and a massive amount of saved time.
Let alone things like health monitoring and that kind of thing.
Cool. So I guess that's probably most of the background. The 4 services that we want to compare today, we've gone ahead and tried to score these based on just that specific example of deploying a HTTP API. Depending on what you're trying to do, obviously you're going to get different scores for all of your different services. It's kind of a classic it depends case.
And depending on your team as well, the skill sets in your team.
Absolutely. So the most important thing that we are trying to share with you guys here is the criteria that we're using to compare all of these different things, because the idea then is you can go away, take some of those criteria and apply them in making some of your own decisions. So we won't specifically pick a winner out of these, but for our specific scenario, there might be one that clearly comes up on top of the others.
That's why it's the PaaS Battle Royale. Okay, so this slide, I think, is probably the most important slide in the deck, and this is the one that we really want you to sort of, I guess, take away from the talk. And this is basically the criteria that we've used to compare these services, and we've broken it down into development concerns and production concerns. Now, most people, when they look at PaaS services, from what we've seen, tend to look at production concerns. They think about things like, what's the scalability and what's the cost? Maybe what's the diagnostics if they're, thinking in the right way.
But usually, how well does it scale? It's always the first one.
Yeah, and these are all, obviously really important, but the development concerns are also really, really important. If you, I guess, force your development team to use a technology that doesn't really match with their way of working or the type of application that they're trying to build, then you're going to just slow them down. And in this day and age, the ability for most companies to be competitive is leveraged on the fact that they can pump out software faster than their competitors. Like there's, time and time again, we see instances of this happening. So these development concerns are actually really important. So I'll briefly describe some of them, and then we'll go into more detail as we go through each service, and you'll start to see real examples of these to sort of really cement it. But in terms of development concerns, we're looking at things like ramp up and learning curve, both of just the development process, but also the ability to provision infrastructure. The frustration factor, which is kind of like once you're ramped up, how annoying is it to use that service for the type of workload that you're trying to build? Ease of local development. If you can't just F5 something locally, if you have to deploy it to be able to see what's going on when you change something, for instance, then that's really frustrating. It really kind of adds a lot of latency to the development process. There's also the features in the PaaS platform. So there'll be some core features like SSL and load balancing and that sort of thing that you would expect to be there, although there's slight differences in some of those core features across, at the very least, the 4 that we looked at. But then there'll also be nice to have features that may or may not be relevant depending on the application that you're building, like service location, health monitoring, stuff like that.
Yeah. So the core things we've picked in our examples are core things that make sense for a web API, and for whatever you're looking at, it depends on what you're trying to deploy.
Yeah. Language supports just how many different languages does it support? Are you restricted in your programming models? And then what restrictions are there about the way you write your app? Like, can you use things like COM or GDI, for instance? In terms of production concerns, we're talking about once you've deployed the thing, how easy is it to find out what's going on if there's a problem? How easy is it to diagnose? What kind of visibility do you get of your running application? What's the cost and density of the PaaS platform? Can I put hundreds of applications in one node, or do I have to have 100 nodes? What's the amount of scale that you can achieve? Is it just tens of nodes? Is it hundreds, thousands? How easy is it to scale? Is it a slider, or do I have to do some complex, PowerShell or whatever else it might be? And how easy is it to deploy the application, and how fast does it take to deploy? Do we have to wait for a VM to spin up, or is it instant? And also, automated deployment's obviously incredibly important. It's what all of us should be doing for production and tests and that sort of thing. But sometimes getting started in a particular PaaS platform, or if you want to quickly try something out, it's quite useful to be able to do a manual deployment. So what kind of capabilities are there around that? Where does it sit on the PaaS continuum, and thus what's the support overhead of it? And also, how easy is it to secure the service and productionize it and make it ready to be consumed in production?
Cool. So an argument, I guess, that we quite often hear when we get to this point is, what about vendor lock-in? How do you go and compare all these different PaaS options if that means that by picking one, you're kind of locked into that particular vendor for everything that you're doing. And we come up against that argument a fair bit. What we are trying to prove as a part of this is that we can take one example, in this case just a simple web API, and deploy that with the same code base to all of these different PaaS options. And that's something that we actually are finding increasingly is really, really possible if you take a little bit of time to think ahead of actually building your applications. It is possible to do things in such a way that you're not taking dependencies on specific vendors that are really hard to break later. So we'll show just a single code base here and show how that's deployed to all these different services.
And I think the nice thing there is it almost allows you to sort of maybe dip your toe in the water and try a couple of different services out without having a huge overhead and without worrying, like laboring too much on, oh, we need to choose the right one first go. The one thing I would say though is, I guess, some of those nice to have features that we talked about, you kind of, in some instances, do need to opt in to a bit of lock-in to get some of them. So, I guess your mileage might vary and it does depend on what you're trying to do.
Cool. So we're both from Perth, and back in Perth we run a conference called D2D Perth. You might know of D2Ds in other states as well. And a common, or I guess a problem that we have back in Perth is coming up with an application where people can pretty easily submit their talks that they want to do for the conference. We've got an app that does that, but we've sort of been thinking, okay, as an example for this, why don't we just try and come up with a really simple submissions API that'll let people submit talks they're interested in doing. And
then we could build a cool React front end on top of it.
Yeah, later. Yeah. So that's the example we're going to be working with. Looks something like this.
So this is kind of just illustrating that fact that Matt just talked around vendor lock-in. So we've got one code base and we've deployed it to container instances, app services, Elastic Beanstalk, and we've also deployed it to Service Fabric in 2 different ways. And we'll probably, if we have time, we'll dig into a little bit why there's 2 different ways. But the same code base works on all of them. We've had it running. Yeah.
Cool. So if we start with app services from Azure, so as Rob said, I think before, it's been around for a number of years now. Really mature service for deploying web applications, has a huge amount of functionality out of the box, and you can actually do not just web applications, but also background jobs and even Linux containers now. So there's quite a lot to it.
So that's actually a misnomer now, IaaS as a service, but it's the way I always describe it because it's a good analogy. So this is the rough architecture of app service. None of this is exposed to you though. This is all completely transparent behind the scenes. It's all completely managed by Microsoft. But basically what happens is you'll get a number of virtual machines that get provisioned and your application will get deployed, or applications will get deployed to all of them. Around that, they've got some stuff around metering. They've got an ability to deploy code into all of those servers, and the deployments are actually quite varied. So you can either use Git repositories, either hosted inside of app service or outside in things like GitHub and Bitbucket and VSDS, or you can use Dropbox or OneDrive, so you can drop a file in and then it automatically gets published. You can use FTP, and you can also use web deploy, which is what we normally use when we're doing deployment pipelines and deployment automation. And then in front of that, they've got various sort of load balancing things to make sure that when you come in from the internet, that you get put on one of the right servers that has your application on it. In terms of the structure of, I suppose, the apps themselves, there's a concept called an app service plan that basically is a wrapper around a number of servers that get provisioned. So all the VMs that get provisioned, as I said before, are completely managed and patched and all that kind of stuff. You just have a slider, you say, I want 3 of them or whatever. And then you can deploy a number of web apps to the app service plan. And then each web app can actually have a number of something called a web job, basically a console app in one of a number of different programming languages. So there's, I guess, you could call it a service worker type model, if that makes sense.
Cool. So shall we show what that looks like?
Yeah, cool. So I guess to give context, let's dive into Visual Studio. Now, we've got our solution here. We've got Conference API. It's a .NET Core application. That's one of the things that actually caused us probably the most amount of pain in the last few days. And this has the application. So if I just Control F5 that, in this case, we've got it running on Kestrel It also runs on IIS Express locally too if we switch it out. And you can see here the default endpoint is API/sessions/submitted. So we've got the submitted sessions. You can see I've done a couple here before the talk. And if we just pop over to Postman, then if we just post to API/sessions, this payload here, we send that, we get back an ID, and if we refresh here, the third item shows up. So that's basically, yeah, nice.
And that's the talk.
And that's it, we're done.
Yeah.
So look, super simple, right? But you can put whatever you want in here. It's just a .NET Core web app. You can put as many things in there as. Is what hard-coded? Oh, sure. It's a good question, actually. It uses SQL Server. So by default in the app, it's actually a very relevant question because obviously one of the things we've had to figure out is when we deploy to each PaaS service, how do we change this configuration setting here so that it works in that PaaS service? It was one of the more interesting things that we had to figure out. So when we're running locally, when we control F5, it's just local DB, conference API database using a trusted connection. So it's just SQL Server and then entity framework call. So nothing too fancy. If you're interested, the controller is super basic. It just creates a new session object, adds it in the context, save changes, and then pulls all of them out. There's no DI or anything. This is pretty dirty code. Don't write stuff like that in production, obviously. Sorry?
In your sort of study, do you deploy a data?
Right, cool. Every single one that's in Azure, we used Azure SQL Database, and the one in AWS, we used RDS. So we didn't bother looking at, we're more looking at the compute stuff, I suppose, rather than the data services. Cool. Do you want to run through the
Yeah, so this is what our little scorecard looks like. So you'll see a few of these for the different services that we're looking at. So dev ramp up, we kind of explained. For an app service, it's really, really simple to get started just because you don't really need to do anything out of the ordinary apart from just building a normal website exactly as you would normally. You don't have to add anything to that website to make an app service work. It all just works out of the box. We have a rating for our infrastructure as code, so our attempt to automate this and deploy the services as well as the application. And
So
for
I
app
might
services,
show that one if you want.
yeah, for app service, you'll see we rated that only a 6 out of 10.
So the reasoning behind that is in order to deploy it, you basically need to understand Azure Resource Manager. And like any kind of reasonably complex automation software or platform, whatever you want to call it, it takes a while to kind of get across the nuances of it. Once you're across it, it's pretty straightforward, and Azure App Service is one of the more easy things in Azure to deploy using it. And this is the file here that we use. So this is an ARM JSON file, and this one's 300 lines of code. I'm not going to describe it because we didn't really have time for that, but the basic idea is there's stuff like a server farm, which is the app service plan, so that's the group of VMs that get deployed. In this case, there's only one instance that gets deployed by default. We can put multiple if we want. There's an App Insights component. App Insights is a PaaS service in Azure that allows you to basically pull out diagnostic information. We'll show that in a sec. We've actually got a service bus that we're not using because we were thinking of doing like a Slack integration, but didn't really have time. Yep. We've got Azure SQL Database, which is what we were just talking about. We've got storage account, which we're also not really using. And then we've got the website itself, along with a bunch of configuration options around the instrumentation key, the ASP.NET environment, and then all of the connection strings. And here's the database connection string and just doing this, by the way, overrides that app settings one because it's named database, and it automatically just overrides that. So that's how that works. So that's basically the IAC.
Yep.
Yeah. Okay.
Yeah. So from a manual deployments perspective, again, pretty simple. It's just like a right-click publish in Visual Studio, or if you aren't even using Visual Studio, you've got other options like FTP.
Yep.
Don't normally recommend it, of course, but
what I've done before, if I wanted to do something quick, is I actually just pull up Windows Explorer, put the FTP endpoint, type the password in, and just copy stuff across.
Yeah.
You can also do that with Dropbox as well. The other really cool thing, the reason why we gave it 10 out of 10, is that you actually also have, as part of Azure App Service, something called the App Service Editor. And this is, and this will look very familiar to most of you because it's VS Code. They basically deployed VS Code into the internet,
pretty cool.
and we can just add like files. I can just be like new file, like lol.json or something like that, and I can just start kind of like coding stuff in there. So what I have done before is just gone like in the portal. I got like a new website, App Service Editor, and I start just popping random stuff in there.
for playing around, for testing things out.
Yeah, and then we YOLO
Not on
it to production.
Yeah. Good. So automated deployments, again, I think we said before, just MS deploy, PowerShell.
It's pretty straightforward.
A whole bunch of options, pretty easy to do. It's also really, really fast. You don't have to wait half an hour or whatever for your instances to come up. It's usually a case
As soon as the files are there, it's deployed.
Yeah, so pretty cool.
You just wait for the app to spin up.
Diagnostics might be another one we'll show. You'd see it's another one we gave 10 out of 10 because it's gotten to a point that's really, really amazing what you can do.
So part of the ARM PowerShell implemented something called an Azure App Service Site extension, which adds in the App Insights extension, and that automatically starts collecting diagnostics. And then we also add the App Insights SDK into our app itself, and that collects a few more diagnostics. And then it's all just built in. So this is the web app here in Azure, and under Application Insights here, we can see it's linked, and we click on View More, and then we've got the Application Insights instance here, and we can see all kinds of stuff in there. I mean, it's got like failed requests, for instance. We've got all of the server response times, just all the server requests. We can start to drill down into this operation failed 284 times. The reason being because it's a 404, and the probe that's hitting it is just getting a 404.
Has structured logging as a part of it as well, which actually attaches to requests, so you can go and search on variables that you've logged and look up specific reasons why things have happened. So there's a huge depth to it. Can do so much.
Yeah, it's really easy to get it running, and you get lots of visibility. So it's really cool.
Cool. In terms of cost, it's reasonably good. You pay a little bit more than you pay for like a regular VM because of the extra stuff that you get on top, but still pretty reasonable. Density is pretty good as well in that you can deploy a whole lot of apps to the same instances or the same VMs that are behind the scenes.
I think there's, depending on the tier you can either deploy, I think 100 apps to a plan in standard tier, and I think it's unlimited in premium from memory.
Yeah, cool. So in terms of
scaling's
ease of scale,
easy.
yeah, that's a cool one to show.
Yeah. So scaling here. You can actually scale vertically by changing the VM size on the fly, which works. And it's instant too. You don't need to wait for the VMs to spin up. They've already got VMs waiting for you, and they just transition you across. And then horizontal scale. In this case, I've got a basic instance, so I can only get up to 3. But if I have standard, it's 10, premium's 100. So you can scale up a reasonable amount. You can't go more than 100 though, unless you do multiple app service plans and then put like a DNS load balancer in front of it. So
it's not really out of the box, so we kind of didn't count that.
So that's why we put 7 out of 10 for that.
Cool. So frustration factor, not very frustrating, pretty easy to use. As you kind of seen, a lot of things are just part of the standard way you would build websites anyway, so pretty solid there. Also fairly easy to productionize. Another one to show, but a lot of things out of the box in terms of the fact that you've got HTTPS just on the default subdomain that they give you. You've got a load balancer already.
So so it's got HTTPS, it's valid HTTPS, it's green, it's on their subdomain as websites.net. You can add your own custom subdomain and add in SSL on top of that as well. But it's just, that's a production ready endpoint out of the box. And if I spin up more instances, then that'll get load balanced across all of them.
Yeah. So pretty good. Bunch of languages supported. You can, out of the box, you can run all sorts of stuff like your Node.js, PHP if you're into that. Anything that's in their supported list of apps, but it's a pretty wide variety of options. So
this is the pre-existing Windows one. There's a new preview for Linux containers as well, and there's stuff like Ruby in that. But in the Windows one, you can use .NET Framework, 2 different versions of it. You can use different versions of PHP. You can use different versions of Java. You can use different versions of Python. It's also got Node.js installed, and you control the version of Node.js that can install as well. So there's a lot of stuff in there by default. You can actually use ISAPI DLLs as well, but I don't think
we haven't, yeah.
no one would do that. It's crazy.
But the fact it's got Linux containers as well just obviously even further opens up what you can do
Yeah,
with it.
which is why we gave it a 10 out of 10.
Yeah. Pretty far to the right in the PaaS continuum, there's some things that obviously you're still restricted on, but it scores pretty well there.
Yeah, and in terms of restrictions, the reason why we gave it a 6 out of 10 is there's a unique sandboxing model that they've implemented. This actually doesn't apply to the containers, but it applies to the stuff that's in the Windows one. And there's certain things you can't use, like GDI and COM and stuff like that. So it does actually restrict, I guess, the way that you build your app. But to be honest, 99% of the time, you would never come across most of those things.
Yeah, still a
the main one's
restriction,
GDI, so things like PDF renderers often don't work. Cool. Azure Service Fabric.
This is our favorite one.
That's because I've been banging my head against a wall for the last 3 weeks on this one. Look, Azure Service
Also has a lot of bugs, though we didn't mention that.
bugs,
Yeah.
app service.
Service Fabric.
Oh, Service Fabric.
No, we'll get to that. It's okay. Yeah.
Oh yeah, don't get me started, mate. So Azure Service Fabric is, look, I'll be honest, it's an amazing platform. Microsoft have done just an incredible job on it, and the fact that they use it to implement Azure SQL Database, Cortana, Cosmo DB, Skype for Business, the Halo 4 backend and stuff like that tells you that this thing is robust, right? That's huge scale. We're talking thousands and thousands and thousands of servers spread all over the world. It's a very impressive technology. But with that, it's also really, really damn complex. And trying to get your head around how to work with it, it's painful.
It's challenging.
It's painful. But we'll get into that when we get to the scores. It does a lot of things. It's quite a comprehensive platform. You've got stuff in here like rolling upgrades and what are the other interesting ones? Self-healing, replication of failover.
Automated rollbacks.
Yeah, all
Amazing.
kinds of crazy things. There's a few different programming models on top of it. In terms of the architecture, there's kind of 2 ways to look at it. There's design time and runtime. In design time, what you do is you define applications, and applications are defined by an application type, and then they will get deployed into a cluster. The application type has a manifest and an application package. Manifest describes which services are used in that application and a few other configuration options. And the package is the thing that gets pushed into the cluster that will then get deployed. And a service or services underneath that application are described by service types. And a service type, again, has a manifest and a package. Manifest describes some stuff around that service, including what endpoints it wants to expose to the outside world and stuff like that, and also what code to run. And then a service will have code, config, and data packages, and they're all of them are optional, so you don't. Actually, the code one might be required. I'm not actually sure about that. I'm assuming it doesn't make sense to not have code, so let's say the code one's required, even if it's not. And then, if you want, you can kind of have config data separately, and they can actually be separately versioned. So you can actually roll out a config change, but keep the code the same, and kind of store config in like separate repositories and stuff like that. And that's where, Microsoft in particular would be using that, so that when they're rolling out a config change, it doesn't take out the entire cloud, and the config change gets rolled, across all the clusters, or along the whole cluster, gradually doing health checks the whole way, and then rolling back and self-healing if it fails, right? So these are the sorts of learnings that you get from, I suppose, a vendor that's running a cloud, right? Now, in terms of services, there's actually 5 different types. You've got stateless services, which are kind of like just normal like web applications. There's stateful services where you can actually hold a bunch of data in memory, and Service Fabric will make sure that memory is, I guess, kept highly available and is kept live across a number of nodes for you.
And the data is in the right place so that all the different nodes can access what they need to, and it's replicated properly and so on.
Yep.
It's pretty cool.
It's also got a container orchestration engine, so it's kind of like Kubernetes in a way, and all the other ones. There's an actor model in there, and then there's something called guest executable, which allows you to basically write any application that you want in any language and just put it there and tell Service Fabric to run it, and it will make sure that it's running, and if it exits out, then it will restart it, and all that kind of stuff. And this is why I actually implemented the Conference API as a stateless service and a guest executable, because in the stateless service, I was able to opt into some of the I guess, programming model inside of Service Fabric, but it meant I had to write a whole heap of extra code and actually another project in Visual Studio that wrapped the other one. Whereas the guest executable, I just took the Kestrel exe that is built and popped it in there and told it to run it, and both of them work. So.
Have you tried the stateful ones? Because the bugs I mentioned are mainly problems with stateful. Like sometimes
Yeah.
in a state where you have to wipe off your whole cluster.
Sure. Yeah. The data backup story for stateful services isn't great. In fact.
For us, what's happening is every now and then what happens is all the data gets lost and it goes in an unhealthy state. We wait 2 hours to load it.
Yeah.
So the reliable dictionaries aren't that great just for this.
Sure. Yeah.
Yeah, just so obviously, just because in this scenario we're just dealing with a web app kind of doesn't make sense. But yeah, it's certainly got some interesting things to work
Yeah,
through.
I think a lot of people just avoid stateful services at this point for some of the reasons you described. In terms of at runtime, what it looks like, the cluster itself manages a series of, the cluster has a series of nodes that subscribe into the cluster, and a node's like a VM, and then the node itself will have a number of service instances deployed into it. So for instance, the Service Fabric cluster might say, oh, this little red one, I'm going to deploy it all over the place and pop it, and then if this one here goes down, then it will move it over here and stuff like that. That's kind of how it works. And from a density perspective, on the left there, you've got the kind of traditional, say, cloud services or whatever model where you only have one application per VM. In Service Fabric, you've got multiple applications per VM because your level of abstraction isn't the VM, it's the cluster itself. And in terms of at runtime, you've got your application type will be deployed as an application, and each service type underneath it will be deployed as a service, and each service, if it's stateful, will have a number of partitions so that you can horizontally scale that data. And then there'll be 3 replicas within each partition to make sure that it's highly available. Or if you're using stateless services like we are, then you always have one partition, and you can have 1 or more instances per deployment, basically.
But hopefully you can see from that the real value comes in when you've got huge numbers of services in lots of different places. You're talking like complex microservices type deployments where there's a lot of them.
Yes.
Because a lot of this value just really comes in from like helping you deal with that level of scale.
Yep.
It's interesting you're comparing cloud services, which is not part of your comparison.
Yeah, I mean, that bit doesn't matter. It was more just saying, the density is that you've got multiple applications.
With app services, it's not true. It's not one service per VM.
Yeah, absolutely. App services is kind of similar. There's a density in absolutely. So, in terms of the scores, look, it does get fairly badly panned, but like, I guess it's not really built for this type of app, right? And this comes down to what we were talking about before. The criteria lineup for Microsoft doing something like Azure SQL databases is probably going to be a lot different in there. And things like dev ramp up don't matter when you've got a huge team that are going to be working on this product for years. Sure, you've got like a few weeks or a couple of months of ramp up pain to get through, but then once that's done, you've got that team skilled up and they can really start using that platform. So yeah, it was super painful. It's super complex, and for 99% of the applications that I see in the wild, this is not the appropriate platform to deploy, right? So infrastructure as code. Okay.
This is interesting to look at.
So I'm not going to scroll through this like I did for app service, but the ARM JSON, and I do have this working, I can go from nothing to a full Service Fabric cluster that works, but it's 900 lines of JSON and about 200 lines of PowerShell. It's damn complex to set one of these things up. It was very painful, but it's very cool, right? So manual deployments, there isn't really, like you can right-click publish in Visual Studio, but that's about it. There's
So we
no,
gave it some points for that.
Yeah, so 5 out of 10, that's fine. Automated deployments, there's a few different steps. It's not as simple as doing like an MS deploy. You have to package up the application. You have to push that application and version into the registry inside of the cluster. Then you need to deploy create an instance of that application with that version, and then tell it to upgrade that application. So it's a few lines of PowerShell. It's not too bad, but it's a little bit more involved. In terms of the speed, it's pretty good. The only thing that would slow you down is if you've got quite a number of nodes and it's doing a slow rollout, then it can take a little bit of time. Local development's actually pretty sweet because now this is not going to work. This is the one thing that's really annoying. So you get this service manager, cluster manager locally, but every time you try to right-click it, 9 times out of 10 it won't actually open. So yeah, it's a bit of a pain, but it looks super pretty when you actually run it up. Now you can have either a 1 node or a 5 node, which is, by the way, the minimum cluster size, locally on your computer. And this is running the exact same thing that's running in the cloud. And the bit I didn't actually point out before is you don't have to run Service Fabric in Azure. You can actually run it on-prem. You can run it in other clouds as well. It's one of the kind of benefits of it, I think. In terms of diagnostics, there's some stuff in there, and you get some logs out there. It's using ETW, which is super painful, to be honest, to use. You can kind of use App Insights, but it's not anywhere near as easy as hooking it up as it is for web apps. And it doesn't really have the kind of agent thing like web apps does. So some of the data kind of wasn't appearing in App Insights that you would normally get if you're using App Service. In terms of cost, right, 5 out of 10 because the minimum cluster size is 5 nodes. So you can't just spin up a 1 node and then kind of scale it out and down as you want. It's kind of a pretty serious bit of infrastructure.
Yeah. So we obviously don't need 5 instances for our little web API.
Yeah. So density, 10 out of 10. You can pack as many applications in there as you want. In terms of ease of scale, you have to deal with VM scale sets. It's a little bit annoying. Scaling the once you've got the VMs provisioned though, scaling the services themselves is reasonably easy. Yeah. Amount of scale, 10 out of 10. There's a really cool video from the last Build conference from the Service Fabric team, and they had a 1,000 node Linux cluster running, how much was it? I think it was, I could be wrong, but I think it was 40 million Docker containers. It was insane. My mind was blown when I was watching this thing. I was like, that can't be real. That's nuts. Yeah. And they're like, let's add another 10 million F5 on this PowerShell script, and it's just climbing up. And it's like, whoa, okay. Yeah. That's what we're dealing with here, right? It's amazing.
It's a pretty good demo.
Yeah. Frustration factor is pretty high. The tooling's pretty janky. There's all kinds. I've got a Trello card of about 50 items of all the annoying things that I found while I was doing this. It was really frustrating to use. And even after I really understood it, it was still quite frustrating. There's still things that would happen that would be really confusing.
Yeah. But hopefully that changes over time, particularly as, for example, some of the bugs that you mentioned get fixed and so on.
Sure. So. Productionizing's it's okay, but you have to deal with all the load balancer and the SSL certificates and all that kind of stuff in your ARM, and it's not trivial to do that, but it's okay. In terms of language support, you can pretty much deploy whatever you want on there, but in terms of the core kind of stateless and stateful services, you're only really working with .NET and Java that have first-class support, so we put that down a little bit to an 8. It's sort of a 6-ish on a PaaS continuum because you're getting closer to the metal at this point. There's not really any restrictions, it's just a VM under the covers. Right, so there's a service that you can deploy that they've created. I think it's a stateless service that coordinates through all of the nodes in the cluster to roll OS updates so that you've only got 1 or 2 at a time that are doing it. And there's, if you're using Azure Service Fabric, then there's a one-liner to enable that in the ARM. But if you're not using Azure Service Fabric, that's fine. They give you the service package and you can deploy it into your cluster. So they've got that covered.
But really important to note that it's opt-in, so
yeah, you don't have to. So
you can do your own.
But why wouldn't you? It would be silly not to use that. But anyway, yeah.
Yeah, sure. Cool. So Azure Container Instances. So container service has been around for a while now, and that's not what we're talking about here. We're actually talking about the newer release, which has only been out for I think a couple of weeks or something like that. So container instances is a way of really quickly deploying Docker containers where you have no knowledge of the underlying virtual machine infrastructure. So whereas in container services, you need to pre-provision VMs and orchestrate them properly, with container instances, you just have no knowledge of what's going on behind the scenes. You just, in a couple of lines, can deploy a container, get it out in a few seconds, and you actually get billed by the second as well, which is pretty unique amongst a lot of the PaaS services we've seen. So I probably don't need to explain what Docker containers are, given like how many Docker talks there have been in this conference, but there's a real distinction, I guess, compared to how you would deploy things on a VM, and a different way that you'd go about doing things in order to get that faster deployment and lower overhead and faster restarts in management and so on. So pretty powerful tools. The container instances support Windows and Linux now. The Windows containers weren't there straight away, but they work now with a couple of little limitations. So pretty cool little service, obviously very simple and easy to explain, and so we thought we'd include that in our list of trials. So I might show really quickly what this looks like in the portal. That would happen. So I'm just going to ignore that error and hope that doesn't affect anything. So you can see that we've got just a simple resource group here called Conference API. Within that, we've got a container group and a container registry. Container registries aren't unique to the container instance service. They actually can be shared across app services as well as container services too. So these are basically locations for you to upload and store your own private Docker images.
Docker Hub.
Yeah. So you can actually deploy container instances straight from things that are on Docker Hub, but you can also put your own private images up here, and that's all platform as a service and managed for you. And you've got your actual container group. So a container group can contain multiple containers. That makes sense. The containers themselves basically share a port space with each other, so they can address each other's networks privately without exposing that outside the container. So you can build up services just by combining a few different containers together, which is pretty cool. The Windows containers at the moment, you can actually, the Windows container groups can only support one instance each at the moment, so that kind of makes them a little bit difficult and creates a pretty big limitation. But the Linux containers at the moment, you can put a number of different containers within a group. That's I guess the general idea of it. So we've gone through and rated these as well, and dev ramp up, pretty strong, pretty easy, because it's all using exactly the same tooling that's been out there for a long time, just with existing Docker applications. The ramp up's pretty easy in that there's tons of tutorials and quick start guides, and not a lot actually goes wrong in terms of setting up your local development environment. The infrastructure as code ramp up, also pretty easy just because it's actually a really simple service. So I'll show you the ARM that we did for this one as well. So if I go, I'll show you in VS Code. If I pull up container instances, so all I've got here is a really simple ARM template to deploy the actual container registry that I showed you. It's only 67 lines, pretty easy to set one of those up. And I've also got one to deploy the containers in a group themselves. So you can see you just basically give it a group name, a list of containers. You specify what each one should have in terms of resources. So I guess unlike a traditional service where you'd say, I want an instance of X fixed size, you've actually got a reasonable amount of flexibility here in terms of specifying just exactly what you need per container, with a few limitations that I'll talk about a little bit later. And then lastly, you can also expose the ports from that shared port space that you want to be out in the wild. So pretty simple and easy to automate and get going. So that's pretty nice.
Alt tab.
Cool. So in terms of manual deployments, we rated that fairly low because there's actually not much out there in terms of manually deploying these. You have to write some kind of PowerShell or interact with it mostly from a command line perspective. You can manually go into the portal and click on a registry image you've deployed, right-click that and say deploy to an instance, and it will go and do that for you, but you've got no way at the moment to manually upload an image to that registry. So for something that I think will definitely improve, obviously it's still a fairly new service.
It's like 2 weeks old, isn't it?
Yeah, can't fault it too much for that. Automated deployment's pretty good. The ARM support, as I showed you, is really easy. PowerShell via the Azure CLI 2 is pretty good as well. Again, easy to continue doing your local development once you've set up your Docker containers and got things running. It's pretty difficult to break what's happening once you've got those initial containers set up. The diagnostics was not great in our experience so far. It's not too bad. You can pull the logs for a container once a container is running. If a container doesn't start properly, you can't actually get to those logs, which is not particularly helpful. You can get to the logs for the container group provider itself. So the object that's deploying your containers, you can kind of see what it's doing, see where it's downloading its images from and trying to deploy them and so on. So that's a really good avenue to look at if for whatever reason you can't get containers up and running. Cost and density are both not great at the moment. This is more, we think, targeted as a type of service that you would use for development, test, really quickly spinning up a container to see if it works, once-off cases, batch processing, things like that are relatively simple.
Especially with that per second billing.
Yeah, so you've got a lot of, I guess, flexibility in that sense, but the actual cost itself at the moment is each group of containers you deploy will take up a fixed amount of resources on an instance, and there's certain minimum costs associated with that. So you don't get the same density that, for example, you got with Service Fabric, which we just showed you.
Or even app service.
Or even app services. In terms of ease of scale, you've got and amount of scale, you've got a fair amount of limitations. So it's easy to scale in the sense that you can just deploy extra containers of the same type, but then that's nowhere near as easy as just like dragging a slider bar to increase your number of deployed containers, for example. So you can still have that level of control if you need to. Your amount of scale is fairly limited. You can only use, I think at the moment, 4 CPU cores and like 14 gigs of RAM. So seems like they're kind of deploying them on maybe like a D3 instance or something like that. But that limits you. You can't use up multiple machines at the moment. If you're trying to do something like that, probably better to look at container services. Frustration factor, it wasn't too frustrating to use. It's pretty cool. You can just go into the portal, run like a line of PowerShell in the portal console and just like deploy a container somewhere with like one line. It's pretty amazing. But in terms of ease of productionizing, again, this kind of doesn't quite seem like it's targeted like that in that you have to do a lot of things yourself. If you want HTTPS, standard Docker, right? So you kind of have to put like another type of container in front to do a reverse proxy through to do your HTTPS, which is what we did in this instance. But every language you can imagine is supported. It's any Linux or Windows container, right? So heaps of flexibility. Pretty far right on the PaaS continuum. The only thing I think that it wasn't perfect on is that you can still open up like whatever ports that you need to, and so you've still got some control in that sense. And the restrictions at the moment, pretty much just what I talked about around multiple containers in a Windows container group. And that's basically all there is for the time being, given all that context around it not really being targeted as a production service.
Cool. On to my favorite PaaS service.
We had to have an AWS one in here.
So yeah, look, I mean, Elastic Beanstalk is sort of a PaaS v1, right? So very thin abstraction over VMs. There is some cool stuff in there around auto scaling and application health monitoring and stuff like that. And I think one of the nice things that Elastic Beanstalk has over Azure Cloud Services, the equivalent in Azure, is that it actually has the concept of an application and a versioned package, and it can roll back and stuff like that, which is something Cloud Services never had.
And store all that history, yeah.
Yeah. So in terms of ramp up, like it's not too bad. Like I thought that was someone
don't
coughing,
think
but it was
that's
actually me.
Yeah.
So look, in terms of dev ramp up, it abstracts most of the kind of complexity of like EC2 and the load balancer and all of that stuff from you. So, for instance, if you go to configuration, you can start to dig in and change some of this stuff, but you certainly don't need to worry about writing CloudFormation or anything like that. It kind of does it for you, and it can provision like RDS for you as well, and then puts the connection string in environment variables and stuff. So there is some nice stuff in there. In terms of infrastructure as code ramp up, kind of put 5 out of 10. The documentation is not great. Once you kind of get how to do it, it's okay. Yeah.
Very similar to what we found for app services in that case. It's kind of complex to get your head around the templating and how all that works. Once you get it working, it's one of the simpler ones. So.
In terms of manual deployments, that's super easy because you just go there and you say upload and deploy. You choose like a zip file on your file system, and it will deploy it for you. So that's quite easy to do. It's not, it doesn't have like the IDE in the cloud like app service did, but it's still pretty easy. Automated deployments aren't too hard. The scripts that we had for that one is reasonably simple. So what we did is we just created like a directory to stage this stuff. We called .NET publish into that directory. We then copied in this AWS Windows deployment manifest.json file, which if you're doing .NET Core, you have to use. And it allows you to define a number of deployments. And this is actually how Elastic Beanstalk supports multiple applications in the same VM, because it didn't used to, but it does now, because that's an array. You can also, as well as ASP.NET Core Web, which basically just copies the file system, the folder in there. It also has a MS deploy one as well, and that's for your kind of more, your MS deploy packages like you would have with a sort of a more typical old school ASP.NET application. And you can also do some configuration of the app pools as well, which is interesting. But yeah, other than that, once we have that kind of published as a zip file, then we basically just need to pop the zip file in S3, tell it that there's a new application version for that application name and and the version label, and then tell Elastic Beanstalk to just update that environment, and then it goes and kind of does it for you. So it's pretty straightforward. The first time you deploy, it takes as long as it takes for the VM to spin up, which is kind of dependent on the size you choose. And I was choosing a T2 Micro at first, and it took like half an hour to deploy. I was really frustrated, but I've got a T2 Medium now, and that's not too bad. I think that's about 10 minutes. But then, and that sucks still, obviously. But the nice thing is that after you deploy once, as long as you're doing an operation that doesn't require it to refresh the server, which would be something like changing load balancers or something like that, then the deployment just keeps the same VM and copies the files onto there, and it takes, I don't know, about 2 minutes, I think. Yeah. So still not like hugely fast, but it's like it's okay. From a cost perspective, you can choose any AWS VM size you want. So it's 10 out of 10. Density is pretty reasonable. You can deploy as many apps as you. Actually, no, it shouldn't be 10 out of 10, should it?
There is a limit. So there's a limitation.
75.
Of 75. Yeah.
I don't know why that's 10. Anyway, there should be probably like an 8 or something. Ease of scale, it's okay. You can go into the configuration thing and change the number of VMs, and you can set up auto scaling rules as well, which is quite nice. Amount of scale, you're limited based on, I think that, and I was a bit confused about this. It seemed like you could only scale up to 20 EC2 instances, but I'm sure that you can do more than that. But this could be a documentation issue. Frustration factor, it's really frustrating to use because whenever anything goes wrong, the diagnostics are pretty terrible. Yeah, that's a good point. So the other problem was X-Ray, which is the equivalent service of App Insights, doesn't work with .NET Core yet. So I couldn't use X-Ray. So you have to request logs, which takes a little while. Then you go into this, and then you've got this god-awful text document, which has all the different log files that it's pulled from. And you just have to kind of scroll and figure out which document you want. And there's stuff like CFN hup there's an init one somewhere as well. There's all these different random logs, and you kind of have to figure out which one's the right one and like what the problem is. And it's just really difficult and frustrating to figure out. Once you kind of get what's going on, it's not too bad. And certainly, there's this ability to define something called EB extensions, which allows you to do things when the VM starts up. It's kind of the extension model, I suppose. And so, like for instance, I was doing iCackles to change the log directory because by default the app pool couldn't write to it. But if you get these slightly wrong, and this is a YAML file as well, then it just doesn't run it, and it doesn't really tell you why. So there's definitely some frustration in there.
Yeah, that was a good experience. Yeah.
But language support, they've got built-in out-of-the-box support for like pretty much every language. Sort of a 5 on the PaaS continuum. You're getting even closer to VMs.
Yeah.
There isn't really any restrictions on there.
Cool. So I guess to kind of wrap that up, obviously, once again, all of the scores that we came up with there are just relevant to what we deployed. Hopefully, some of that gave you some ideas on different mechanisms that you can use to compare different PaaS services. Obviously, the winner's not that important, but in the case of the web application we're deploying, like obviously App Service came up with the highest scores, and it is probably out of all of them the one that's most designed for what we were doing. So that's kind of what we picked up through that exercise.
Yep. Cool. And that is it. And I think we're like 30 seconds ahead.
Thank you very much.